Well, good morning. Yes, and today we're still talking about polynomials, polynomial functions, and so today we're going to learn a little bit more characteristics about those, what it means to be polynomial. So we're going to look at a function that has the characteristics of being polynomial that has a series of monomials. Monomials being a single term. It can be a number, it can be variables, or the products of those variables. That's what a monomial is. But we're going to take those monomials, characterized in this notation of a variable being raised to a power and then being multiplied by some what we call coefficient. So as the polynomial is being written, the next term, if there is one that exists, is going to be written in a series of what we call descending order. So this is called the standard form of the polynomial. So each subsequent term we're going to write, and it will be in descending order. Notice that the power, we call this the degree. With the variable and its exponent, the dependent variable, or the domain, we call it, that variable has a power on it on this term. That's called the degree of the term. This degree is the highest degree of any of the terms in the specific polynomial. Subsequent terms or subsequent pieces of that polynomial will be of lesser degree, less value on the polynomial. So that's a variable of n, or a power of n, and this has a power of n minus 1, so it gets less as we goes on. Well, this could go on forever. You get an infinite, literally, number of terms, and then ending, possibly terminating with a to the with a coefficient down to the first degree term, the linear term we call it, or and then the last one being a constant term. So you're hearing some of this vocabulary as we identify these terms of a polynomial function. This is a polynomial function, a series of monomials that are added together either in positive or negative coefficients to determine and define what that is. So the degree of the polynomial is identified by its leading term. Whatever that largest degree is. Well, believe it or not, you have been studying this in this course. We've looked at linear functions, that's polynomial. We've looked at constant functions, that's a polynomial. We've looked at quadratic and studied those extensively. That's a polynomial. So what they've offered for you is some identification using the vocabulary that we're becoming familiar with. And standard form of this polynomial means that we're going to write it in descending order. Okay, so we've learned that, or what they've identified for us here is how to determine the degree of the polynomial, how to determine what type it is, and we have some names for a few of these polynomials that we'll offer for you this morning. How to write that in standard form. And then, I'll give you an example of that. So that's a table that they provided for us. I want to go through it. They did give us that as there's a degree of 0. And we call that a constant type of polynomial. That constant type. Constant means that we've written in standard form, where it would be an example of a function where all you have is a constant term. All you have is a coefficient. All you have is a number. Here's an example. And remember our piecewise functions where we're out here moving. We had times where we were standing still, and we had a function that was modeled by just a constant term, a number, no variable. Or it does have a variable. We know that we have that variable could be raised to the 0 power. Anything raised to the 0 power is 1. 20 times 1 is 20. Therefore, what is the degree of this term? It is 0, because the variable has an exponent or a power of 0. Now, we don't write that typically because we don't need to. because we know x to the 0 power is 1, and 1 times that ain't any numbers. But that's a constant polynomial. Constant, always the same. The graph of it would be a flat line where the slope is 0. It's never rising, always just running when you're standing still out and you're moving me. We have a degree of 1. Why is it the degree 1, 0? Because the exponent is 0 on the variable. Why is this a degree of 1? Well, because it's linear. And we've studied those. We've studied those considerably. And those linear functions, those linear polynomials, look like you have a linear term. And you can also have a constant term. So what's the degree of this term? The degree? Well, it's the power on that variable, x, 1. So that's the degree, that's why it's 1. Here's an example. We can add to this constant term some linear term. And again, that would be moving at a speed of 3 feet per second when you were moving out here. And it would cross the y-axis or the starting line at 20 if you extended that on that being the b. So these are things that we've studied. We have also studied quadratic types. Quadratics, what do you think? What kind of degrees, what kind of terms is it going to have? That's right, it's going to have a quadratic term, a second degree term. We know that these graph as used, that open up or down in quadratic fashion. We use those quite a bit. Again, we can also have a linear term in there and a constant term. Not necessary, we don't have to, but we must have a quadratic term for it to be considered a quadratic type. Examples of those that we've worked with, we could add a quadratic term to the linear and to the constant. That way we have it. Again, we don't have to have a linear and constant. We must have the quadratic. This degree of polynomial is 2. Why? Because its leading coefficient has a degree of 2. Second degree polynomial. But there's 2 others that we're going to introduce to you. Some of you use them in your algebraic artwork. Cubic functions. Again, that's going to have a cubic, a third degree term in it. It's got to have a third degree term in there for it to be identified as cubic. It can have a quadratic, it can have a linear, it can have a constant term, but it must have a cubic term, a third degree term in there. In a standard form, you'd write that third degree first, and then every other term that you might have in there after it. Again, that particular example of that would be some coefficient you could have. 1 is the coefficient with the cubic term of x. And again, adding quadratic and always. The last one is the quartic. The quartic type of function. That quartic function has a, what do you think? That's right. And you see a pattern? Quartic, if it's 4th degree, it's got to have a term in there that has what degree in it? 4th degree. That means that that function is going to have some coefficient multiplied to a variable, a domain, a dependent variable, independent variable of degree 4. Does that make sense? You see the pattern? Again, we could add a cubic term in there, a quadratic term in there, a linear term in there, a constant term in there, or any combination of those. But it must have a quartic term for it to be considered a quartic type and have a degree of 4. Okay? So again, you'd have to have some coefficient other than 0 times a 4th degree term. Ladies and gentlemen, that's polynomials. One very last vital consideration. A string of terms that are stuck together to be considered to be polynomial. All of the degrees of every single term must be whole number. Must be either 0, 1, 2, 3, 4, 5, 6, 7, 8. Never any fractions. Never any negatives. Never any decimals. Every degree, every power of every term, every power on every independent variable has got to be a whole number. It can be 0, like a constant. It can be 1, like a linear. It can be quadratic. It can be 2. But you can't have an x to the 1/2. If you ever see that in any of the terms, You can have those, but if you see that, it's not a polynomial function. Did you hear that? It's a video, back it up. I don't have to repeat it. So that as you go through this, we want you to be able to identify, is it polynomial? Can you identify the degree? Can you determine what type it is? It's going to the name that we have on it. Can you write it in standard form? And can you see an example of what might look like what we've worked with in the past with our different functions? Hey, we're starting our polynomial world. We're going to learn lots of things about it in this chapter, in this unit of study. We are the Ask Academy.